Alright, so chapter 9 and 11 we combined into just one review video here. These are the last chapters that we got to, and we did pretty well on them. So since they're most recent, we're going to kind of combine them. They're both looking at right triangles. Okay, so if it's a right triangle, we can use the Pythagorean theorem to find the missing side length. So a squared plus b squared equals c squared. C has to be the hypotenuse. Okay, try that first. If it doesn't work for the Pythagorean theorem, then go to the 45, 45, 90 shortcut. See if it's a special right triangle. So if this is a 45, 45, 90, opposite the 45s are your congruent legs. Remember, those would be the same measure. So we could say both legs have length x. If I was moving towards the hypotenuse, starting with a leg, looking for the hypotenuse length, I'd have to multiply it by the square root of 2 to get x root 2. When I'm at the hypotenuse and I'm looking for a leg, that's when I have to divide by root 2. I can have a 30, 60, 90 shortcut, opposite my shortest sides, the smallest angle, medium side, medium angle. There's my right angle. The short leg is x, your hypotenuse is 2x. The long leg, opposite the 60, is x root 3. When I'm going from the short leg to the hypotenuse, I have to multiply by 2. When I'm going from the hypotenuse towards the short leg, always find that next, I would have to divide by 2. If I start with the short leg, I would have to multiply by the square root of 3 to get the long leg. If I had the long leg length, I would need to find the short leg next, and that's done by dividing by the square root of 3. Okay, if it's not a special right triangle, your SOHCAHTOA will work. Remember that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent's your opposite over the adjacent. That only works if it's right triangles. But for any triangle, we can find the area. That's 1/2 times your base and your height. Remember, make a little note that the height has to be perpendicular to the base. For your perimeter, add up all 3 sides since it's a triangle. It's like the distance that you're walking around the triangle. Remember, here we have units squared. Here for perimeter it would just be units. Okay, so what do we use to find missing angle measures in right triangle? That would be either inverse sine, inverse cosine, or tangent inverse. Those are special buttons on your calculators. Okay, if we wanted to simplify these following radicals, we're going to leave the square root signs in there so that we don't have any decimals. Okay, if we're adding, we can only combine the ones that have square roots of 3 together. So I had 7 and 4 to give me 11 of those square root of 3's. And I still have 4 square root of 2's. That's exact. Here in my fraction, since I have a common denominator, I'm going to leave that as a square root of 2 on the top. 67 plus 5 is 72. Then if I take 4 root 2 and square it, I'm squaring the 4 and the square root of 2. So I have 4 squared and then root 2 squared. This is 16. Remember, if I take the square root of something and then square it, they really cancel. This is just a 2. So the final answer here would be 32. And if they're both being multiplied together, I can put them under the same radical. So this would be the square root of 70. No decimals, those are exact. Then in chapter 11 we talked about the unit circle. It has its center at the origin at 0, 0, and the radius of 1 unit. That's why we call it the unit circle. Those x and y coordinates are really the same as the cosine of theta and the sine of theta. Cosine for your x's, sine for your y's. Reference angles are the angles formed by the radius of the unit circle and the x-axis. Remember, these are on the very bottom of your gold sheet. They're by these filled in shapes. You could either have a triangle or a plus sign or a square. Your reference angles are always 30, 45, or 60 degrees. Okay, so if you're rotating more than 360 degrees, so if your theta value is greater than 360, just keep subtracting 360 until you can find it on the unit circle. Otherwise, if it's negative, keep adding 360 until it's greater than or equal to 0. Then you would still rotate counterclockwise like normal. So your tangent comes from if you add the sine value and you're dividing it by the cosine, it's your y's over your x's. If you end up with 0 over -1, this would be a value of 0. Okay, if you're dividing by 0, type that into your calculator, it'll give you an error. This is when it's undefined. So we measured angles in degrees, we also measured them in radians. So pi radians is the same as 180 degrees. So when you're converting from radians to degrees, you're going to multiply by 180 over pi. Or this one has a shortcut. Every time you see pi, just plug in 180 since they're equal. Otherwise, if you're going from degrees to radians, you're going to multiply by pi over 180. And you'll have to reduce the fraction. But you'll leave pi in the answer to make it exact. And then it's time for you to practice.